All right, interquartile range. Take any set of data, divide it into fourths. That's what a fourth means, is quarter. Quartile comes from the word quarter. So speaking of the first quarter here, if you take this data here, 7 and 8, that's we got a fourth of the data there. Then we take the next quarter, between 11 and 8. We have another fourth of the quarter, a quarter of the data right there, fourth of the data there. And let's go blue this time, from 11 to 14. That's how much the data goes there. And then finally, let's go orange, and from 14 to 16, that's how much of the data is there. So what is the range for all of this data? Well, that's going to be the max right over here, the 16, minus the min right over here, which is 7, and that gives us 9. That's the range. And if you were to count, the bunny hops. The bunny starts on 7 and hops 1, 2, 3, 4, 5, 6, 7, 8, 9 times. That's the range. And again, that's the range for all the data. So I'll take a nice little yellow highlighter and I'll show you. This is the range for all the data. But what is the interquartile range? That's just talking about the range from this 8, this first quarter, to this 14, which is the third quarter, the interquartile, the interquarters. And we'll just take a nice little highlighter, such as a nice dark red, to represent the interquartile range from here to here. That would be from the 8 to the 14. So all we do is subtract 14 minus 8, and we get 8, 9, 10, 11, 12, 13, 14. Is that 6? Yes, it is. So that's the range. And if you get the bunny hopping, I'll get the bunny hopping with that nice red again. And I'm going to thin it out. Here we go. Ready? Bunny starts on 8. Bunny hops 1 time, 2 times, 3, 4, 5, and 6 times. That's the range. Interquartile range. Interquartile range of this data set. Let's go. Q1 is right here. That's if we fill in the numbers here, 20 to 24. Each one of these is going to be worth 1, 21, 22, 23, 24. So the first quarter is 21. This quarter here, this is 28, this is 29, 30, 31. So we take, that's the second quarter. Third quarter, we take the 21 and the 31 and subtract. Take 31 minus the 21. 31 minus 21 is 10. Data shows years 9. Okay, interquartile range. First, we got to break it down. And I lied by that. I mean, put them in order from least to greatest. Now let's break it down like this. I want to mark off. There to here. Oh, there. I'm trying to get closer to the middle. Am I to the middle yet? Boom, boom. And finally, the middle. There's the median. Now we need to find the quarters. Watch this. I'm going to use the same color. Now I'm just going to go green here. Green, green. Am I to the middle yet? Green, green. The middle is going to be in between 11 and 13, which is a nice little 12. There's our Q1. We're halfway there, sort of. All right, next, let's find the Q on the other side. Cross off this one and the 20. Cross off the 18.5 and the 19. Oh, it's in between here. So what's in between 18.5 and 19? We draw a number line. 18.5, 19. What would be in the middle of that? Well, I just go ahead and fill in the rest of these decimals here. 18.5, 18.6, 18.7, 8.8, 18.9, and then finally 19. What's in the middle? Let's see here. Let's cross off one at a time. I'll do a nice little red here. Cross this one off, cross this one off. Get to the middle. Uh-oh, both of these numbers are in the middle. So what's in between 18.7 and 18.8? That would be 18.75. That's what's in the middle. You said, that's too complicated. Isn't there an easy way to do this, Mr. Hoffman? Yeah, I think there is. It's called the mean. Find the mean of these two numbers, 18.5 and 19. For what is the mean? You add them up, add up the data points and divide by how many data points you have, the number of data points. So 18.5 plus 19 gives us 17, 37.5. Now divide by how many data points you have. We have 2 data points. Here's the first data point, which is 18.5. Our second data point is 19. So divide 37.5 by 2 and see what you get. And regardless if you do this on a calculator or if you do it a calculator like this, Or if you do it with long division, you're going to get 18.75. So if you take a look up here, the top right-hand side, I took the first or the third quarter minus the first quarter, the 18.75 minus the 12 gives us the IQR, the interquartile range, which is 6.75. Next, interquartile range of this data set. Okay, so let's find the median first. Cross off one on each side, cross off one on each side till I get to the middle, cross one on each side till I get to the middle, cross one. So it's got to be in the middle of this between 28 and 33. Okay, so what's in the middle of 28 and 33? So you could keep going until we get to the middle. Ah, these two are in the middle. Ah, what's in the middle of 30 and 31? That would be 30.5. That's our median. Now let's get to our quarters. I just realized we don't even need to find the median. We just need to know that there's some number here. Because through the interquartile range, you don't need the median. All you need is the Q3 and the Q1. So I'm doing Q3 minus Q1. That's all you need, equals interquartile range. So I'm actually doing more work than I need to. So please don't do any extra work like I did if you don't have to. All right, so now let's find what's in the middle of here. Right now, what's in the middle of here? Now we have to do a little bit of work. Well, kind of, sort of. See, it's not the 10, 28. What's in the, oh, it's in the middle of these two. What's in the middle of 23? That's easy. So here's our Q1. Now let's get the Q3, other side. Here we go. It's not here, here, here. It's in the middle, in between 47 and 80. Now that is a big jump. Instead of writing out a number line like this, I'm going to just get the mean, which is add up the two data points and divide by 2. Add up the data points and divide by how many data points? 2 data points. Add them up, 47, 80 divided by 2. I'm going to do this the bottom left-hand side, 80 plus 47. It's 127. 127 divided by 2, if you do it in the calculator, which I'm going to do. And I end up with a 63.5 is the IQR. Next. Okay, so OMHS has you figuring out lower fences, upper fences, and all that fun stuff. But the only thing you really need to know here is something that is strikingly, any data point that strikes you as being way far away from the other data points. Particular, we could say the median. So to pick one of our answer choices here, let's take a look at the data and put it in order. I put it in order here. Now, if you look at these data points, do any of them jump out at you as saying, I'm way kind of far away from the others? Not really. I want to say not really to me either. Yeah, they all kind of seem pretty close to each other. But if you put it in a box plot, you might see something revealing here. And it says click. I'm going to have to delete this. Cut. Aha! Now, which one of these data points seems to be kind of far away? Well, not so much from the other data points necessarily, but from the median. Yeah, so maybe that's what we do. Let's look at the median. Find the median first, and then we'll see which, that might help us, rather than calculating the upper fences and lower fences, which is something that you would probably do in high school. Let's just find the median. Now, the median's 84. Now, which one of these numbers is really far away from 84? Well, if you look at 88, that's only 4 units, but if you look at the min, 66, that's a lot more than 4, and if that, yeah, that's way out there. So if I had to pick, I'd say 66 is way out there. So yeah, I'd say it's probably the first answer here. And lower fence or no fence. By the way, the fences are kind of like, okay, the fences are like, okay, well, from the median to some point is your upper fence, and then from the median, we'll do purple. From some point, I don't know where out here, but somewhere around here, I'm probably closer to here, is going to be your lower fence. Lower fence and upper fence, but you don't really need that because look how glaring this is. This is 66 is glaring at you. It's like, I'm way out here. I'm an outlier. And I spelled liar. That actually it's called liar. Our outlier in math is spelled the way that I just highlighted in green, but I like to do the way that I highlighted in blue because it's like lying to us and it's way out there. It's kind of like not representing the truth of the data. Next. So let's do the same thing here. Let's look at that median, all right, and see which one of these data, oh, is this the same thing we just did? I'll be darned, it is. So you find the median. Yeah, okay. Oh no, this is the other way around. Could you tell that before I revealed it? If you rewind this and pretend like I just didn't show you what I just showed you. 69, which one of these is really far away from 69? Well, this time if we look at the min, That's only 65 to 69 is only 4 units. But if we look at here, going from the median to the max, that's a lot more. That's 80 minus 69 is pretty far out there. That's 11 units. So if I had to pick an outlier, it'd probably be this one here. If you had to pick just one. Hmm. Yeah, I would think that 78 might be an outlier too. But they're telling us, are they telling us to pick one outlier or two? 65. Not based on these choices, I'm thinking it's just this one right here because it's greater than the upper fence if we calculated the upper fence. All right. How about this one? Which one is really far away from the median? 46 all the way to 57, 46 to 42. This is only what, 2, 3, 4, 5, 6, 4 units. This one's a lot. This is like 11 units again. Let's see what this does. Or is this the same thing I just showed you? Cut. Yeah, that 57, that was 57's way out there. And yeah, 48's not. This is a big jump. This is like a blatant glaring jump, right? This is egregious. Egregious. 57, 57. The next data point's 48. 48's way over here. So that's a big jump. There's no data in between. So this is really an outlier, I think. Probably a sole outlier. If you had to pick one, that would be the one. How about this one? Can you tell by looking at here which one of these data points is really not like the rest? I can. Take a look. How about now if we put them in order? Now that I put them in order, can you tell which one kind of stands out and really far away from the rest? Okay, now that we've identified the median, which one is really far away from the median? If we go to the min, that's pretty far. 35 to 23, 23, 3, 4, 5. What is that? Come on, I can do mental math, but I'm afraid to. 12, okay. And then what about going to the max? Oh, wait a minute here. 90 minus 35. Holy smokes. See, 40, 50, 60, 70, 80, 90, 50. I think that's 55. 40, 50, 60, 70, 80, 90. Yeah, 55. Oh, yeah, that's a huge jump. And what does that look like on the box plot? It's really going to be striking. Yeah, check out that. I mean, that 90 is out of outer space. He's an outer space liar. He's lying so bad he's in outer space. That's how bad of a liar he is. So you better notice somebody who's telling you he's close to you, but he's in outer space, or she's close to you, but she's in outer space. Yeah, outlier. Don't even try it. Okay, how about here? Can you tell which one of these data points kind of jumps out from the rest? How about now? Looking at the median, which one's really far away from the median? Well, usually you got to pick probably between the max and the min. They're the ones that are furthest away. 5 units. Oh yeah, 15 all the way to 40. That's what, 35 units? No, 25, 15, 20. That's 25. 25 units. Yeah, that's gotta be it. What does the box plot tell us? Come on, box plot, box. Come on, blot pox. It's a yeah. Anyway, 40's way out there. Check it out. Next. Come on, guys. Come on. Which one of these numbers is not like the rest? Yeah, you've got this one, right? Now, which one of these numbers is not like the rest? How about from the median? Which one of these numbers is far from the median? 110 max, 20. This is like 10 units. Oh yeah, come on. This is what, 70, 80 units? You're way out there, Mr. 100, Mr. 100, 110, 110, 110. Outer space. Peace out, Panthers. Pride, passion, purpose.